Dear students, so far you have gone through various concepts in Six Sigma, starting from quality fundamentals, total quality management, and subsequently the probability and statistics analysis, and then quality function deployment and various tools and techniques. Now we are in the 7th week and you have already attempted 6 assignments, which must have given you the wide exposure as well as the confidence in solving the various problems and addressing the various issues in the domain of Six Sigma. Today I will be presenting the solution of assignment 7, which mainly addresses measurement system analysis and OC curve, that is operating characteristic curve. Like other assignments, we have 25 questions, each carries 1 point. All questions are objective type, only one answer is correct per numbered item, and one more instruction I have added, that is questions number 6, 7, 8 are common data question. So there is a common data given for question number 6, 7 and 8, and there are 3 questions. Question 1, observational error can be defined as, the various options are: A, difference between a value measured and the true value, difference between the true value and value measured, C, absolute difference between a value measured and the true value, and D, all of the above. The correct answer to question 1 is A, difference between value measured and the true value. Question number 2, you can see figure divided into a parts A, B, C and D. The question is, Mr. Mishra had participated in shooting event. The following A, B, C and D instances were observed for Mr. Mishra. How would you describe the shooting of Mr. Mishra? You are given 4 different options, and basically some event out of A, B and C, D are tagged as precise or accurate, and you need to figure out that a particular event should be called precise or accurate or both. So the correct answer is answer D, a precise but not accurate, B, neither precise nor accurate, C, accurate but not precise, and D, precise and accurate. So the answer which correctly represent the A, B and C and D options is answer D. Question 3, in sequential sampling plan, option A, maximum 2 samples are taken, B, maximum 3 samples are taken, C, maximum 4 samples are taken, and D, samples are accumulated at each stage till the decision of accepting or rejecting a lot is taken. So the correct answer is D, samples are accumulated at each stage till the decision of accepting or rejecting a lot is taken. Question 4, you have 4 statements. Read the following statements carefully and mark the correct choice. Option A, statement 3 and 4 is correct, B, statement 1 and 2 is correct, C, statement 1 and 3 is correct, and D, statement 2 and 4 is correct. The correct answer is A, statement 3 and 4 is correct. Statement 3, reproducibility is caused by operator, and operator training should be provided for this, and statement 4, repeatability is caused by gauge, and gauge maintenance is necessary for mitigating the repeatability error. Now we have common data question, and this data useful for next 3 questions. Question number 5, 6 and 7. Let us look at the data. Conduct a gauge R&R study of the following data where 5 parts are evaluated by twice by 3 operators. So, the data tabulation is like this. There are 3 operators, operator A, operator B and operator C. Each operator is evaluating 5 parts, 1, 2, 3, 4 and 5, and if you see, then each operator evaluates twice. So, you have on left side part, that is 1, 2, 3, 4, 5 and number of times it is 1 and 2. You are also given the table for calculation of D2 in gauge R&R studies, and here you have number of observations in sample and you need to find the factor D2 for estimating sigma from R bar. So, having gone through the lecture, you must have appreciated the concept of gauge R&R and how the computation is performed. Now, if we look at the question 5, then what would be the value of sigma repeatability and sigma reproducibility? The options are on the screen. A 5.49 and 4.38, B 2.91 and 8.24, C 4.38 and 5.49 and D 8.24 and 2.91. If we look at the correct answer, then answer C is the correct one, which is 4.38 and 5.49. Here some computation is involved and you would be interested to learn the solution of this problem. So, I have reproduced the table and I computed x bar. You can see it here. This is the x bar, and for these two the x bar value is 113.5. Same way the x bar is computed. You can see the value of R, that is range. 114 minus 113 is 7, 113 minus 106 is 7 and so on. So, you have x bar and R value for all the parts. I have also computed R bar and x double bar. X double bar is the average of x bar, which is the average of these readings, and it comes out to be 103.1 for operator A. You can look at the value of R bar. It is basically the average value of all R, and for operator A this value is 6.2. Similar way for operator B, you can see the x double bar, the value of average of the averages is 102.8 and R bar is 2.8. Similar way, x double bar for operator C is 112.1 and R bar is 5.8. You can refer the notations and their meaning. X bar is equal to mean value and the sample calculation is shown. R is x max minus x mean. The sample calculation is shown for operator A part 1, and same way x double bar and R bar computed for operator A. Now, we are interested in calculating sigma reproducibility and repeatability. Let us see the first sigma repeatability. So, you have R bar value, average value of R bar, you can also call it as R double bar. Here I have written it in words, that is average value of R bar equal to 6.2 plus 2.8 plus 5.8 divided by 3. You can very well see that 6.2 plus 2.8 plus 5.8 divided by 3, which is 4.93. Sigma repeatability is equal to R bar divided by D2, and this will be 4.93 divided by 1.128. Now, from where the D2 has come? So, along with the data, I have also presented a table which had represented the values of D2 for different you can see here for different number of observations in sample. So, now if we look at, then we have two measurements. So, different number of observation in a sample should be said as 2 for this, and the corresponding value of D2 corresponding to 2 is 1.128, and hence sigma repeatability is 4.38. You can compute sigma reproducibility. The expression is Rx double bar divided by D2, where Rx double bar is equal to x bar maximum minus x bar minimum, and putting the value in the expression you will get sigma reproducibility 5.49, and again value of D2 for 3 is taken from the suggested table 1. Now, let us look at the question 6, where we would again be using the same data set. What would be the value of sigma r and r square? You are given the 4 options: 76.35, 49.35, 67.35 and 94.35. The correct answer is B, 49.35. So, sigma r and r square, as you know, is equal to sigma square repeatability plus sigma square reproducibility, and from previous solution we have obtained the values of these two, and by substituting you will get sigma r and r square is equal to 49.35. Question 7. In the video lecture, you have also studied the concept called P by T, that is precision by tolerance ratio, and what would be the P by T ratio for operator B. You are given 4 options on the screen, and the correct answer is A, that is 1.03. You can see the computation. The standard expression for finding P by T, precision by tolerance ratio, is equal to 5.15 sigma r and r divided by tolerance, and you can substitute the values. You have already found sigma square r and r, take the square root, and sigma r and r is 7.08, tolerance is USL minus LSL, and putting these values in P by T equation you will get 1.03. So, the correct answer is 1.03. Question number 8. You are supposed to match the given preferences: A, acceptance quality level; B, lot tolerance percent defective; and C, consumer's risk; and D is producer's risk. You are given the definitions on the right hand side, and one is the probability that a lot containing acceptable quality level will be rejected. Second, the upper limit on the percentage of defects that a consumer is willing to accept. 3, the probability that a lot contain defectives exceeding the LTPD will be accepted, and 4, the percentage of defects at which consumers are willing to accept lot as good. You can see the options on the screen A, B, C and D, and the correct answer is A, where A is appropriately matching with 4, which is percentage of defect that at which consumers are willing to accept lot as good. B is perfectly matching with 2, that is LTPD is upper limit on the percentage of defects that a consumer is willing to accept. C, consumer's risk, is matching with 3, the probability that a lot contain defectives exceeding the LTPD will be accepted, and producer's risk is matching with 1, that is the probability that a lot containing acceptable quality level will be rejected. Question number 9. In double sampling plan, if the numbers of defect is in between the two cutoff numbers C1 and C2, then A. Accept the lot, B. Reject the lot, C. Take another sample, D. None of this. The correct answer is C. Take another sample, because we are not able to make the decision and it is in between C1 and C2. So, we will go for another sample. Question 10. Which of the following statement is not true regarding the producer's risk? So, you are given some 4 options. A. Chance of committing type 1 error, which means accepting a good lot. B. Chance of committing type 1 error, which adds unnecessarily to the lead time for finished products or services. C. Generally it is kept around 5% for industry. And D. Type 1 errors create poor relations with the producer. A careful thinking will tell you that the correct answer for this question is A. It means chance of correcting type 1 error, which means accepting a good lot, is not correct. It is actually chance of committing type 1 error, which means rejecting a good lot. This can result in a poor relationship with the producer, because here producer has to bear the loss. Question 11. A graphic display of the performance of a sampling plan showing the probability of accepting the lot for a range of proportions is called A. Exponential curve, B. Normal distribution, C. Binomial distribution, and D. Operating characteristic curve. You can easily identify that the correct answer is D, which is operating characteristic curve. Question 12. You have also studied about the rectified inspection in your lectures, and here the question is, a rectified inspection assumes that all defective items in the lot will be A. replaced with good items if the lot is rejected, and that any defective items in the sample will be replaced if the lot is accepted. Similar way, B. replaced with good items if the lot is accepted, and that any defective items in the sample will be replaced if the lot is accepted. You can easily read out similar way C and D options. Here the correct answer is D. It means replaced with good items if the lot is rejected, and that any defective items in the sample will be replaced if the lot is rejected. Let us look at the question 13. Here you are asked to match left hand side and right hand side. On left side you have 3 options: A. stability, B. reproducibility, C. repeatability, and you are given the probable explanation of each particular term on the right hand side as 1, 2 and 3, and you have 4 options A, B, C, D on the screen, and you are supposed to match correctly. So the correct answer for this question is answer C. A is matching with 3, B is related to 1, and C is matching with 2. So stability, the difference in the average of at least 2 sets of measurement obtained with a gauge over time. Reproducibility, you have studied, it is variation in the average of measurement made by different operators using the same gauge measuring the same part. And C, repeatability, the random variation in the measurement when one operator uses the same gauge to measure the same part several times. Question 14. Which of the following statements are true regarding single sampling plans? Statement 1. The lot under test will be rejected if the total defective items in the sample exceed an acceptance number C. Statement 2, all items of a random sample of size n must be defined and tested. And statement 3, a rejected sample results in 100% sampling or return of the lot to the producer. You can look at the options A, B, C and D and find out which one is correct. The correct answer for question 14 is D. Statement 1, 2 and 3 are correct. Question 15. In single sampling plan, if you want to check the defective items of a lot of finite size, for example, for a truck or bus, in this case which distribution will be preferred, and for this distribution which type of OC curve will be used. Just to remind you that in the video lecture you have learned about the distributions applied in such kind of situation and also type A and type B OC curve for finite and infinite lot inspection. Now here you are given the 4 options: A, binomial distribution and type A OC curve, B, binomial distribution and type B OC curve, C, hypergeometric distribution and type A OC curve, and D, hypergeometric distribution and type B OC curve. The correct answer is C, hypergeometric distribution and type A OC curve, and here it is a case of finite lot. Question 16. The maximum value of the average outgoing quality over all possible values of the proportion defective is called A, acceptable quality level AQL, B, lot tolerance proportion defective LTPD, C, average outgoing quality level AOQ, and D, average outgoing quality limit AOQL. The correct answer is D, that is average outgoing quality limit. Question 17. Which one of the following statements is wrong in reference to ideal OC curve? You have 4 options. A, the probability of acceptance should be very close to 1. B, it accepts everything near the AQL value and reject everything which beyond AQL. C, the only way to realize the ideal OC curve is 100% inspection. And D, if sample size n is small, the OC curve shape will approach the ideal OC curve. You can see the solution, and correct answer is D, that is if sample size n is small, the OC curve shape will approach to ideal OC curve. This sentence is not correct in reference to ideal OC curve. We have question 18, and here you can see that you are given 3 samples, and these samples based on inspection n is equal to 600, n is equal to 3000, n is equal to infinity, and you have small n, that is the sample size 30, 30 and 30, and you are also given the value of C is equal to 1, 1 and 1. Now which type of OC curve is suitable for following samples? You can carefully look at A, B, C and D and also recollect your understanding about type A and type B OC curve, and the correct answer is C, that is sample 1 you go for type A OC curve, sample 2 finite type A OC curve, sample 3 infinite type B OC curve. You have seen the characteristic curve, operating characteristic curve, and how it is plotted in the video lecture. Once again, you just look at this curve, and the question is the various areas are marked at A, B, C and D, and you are supposed to tell which one represents producer's risk, which one represents consumer's risk, which one represents AQL, and which one is RQL. You can see the options A, B, C and D carefully on the screen, and the correct answer is A. So, the A indicated is basically producer's risk. The B arrow pointing at point 1 indicates the consumer's risk. C at 1% is basically AQL, and D at 6% is RQL. Question 20. In general, beta is the probability of acceptance of lot at RQL level and alpha is the chance of rejecting a lot. For OC curve, the value of alpha and beta is supposed to be. So, most widely used values you are supposed to suggest, and you are given the options A, B, C, D. So, the correct answer is D, alpha is equal to 0.05 and beta is equal to 0.1. Question 21. A lot of 100 books contain 20 defective ones. If an operator randomly sample 15 books, what is the probability of 12 books defective? Now, you have 4 options, and if you know the distribution and its probability distribution function, then easily you can identify that which option is correct. So, here the appropriate distribution is hypergeometric distribution. It is given as PD is equal to RCM n minus R Cn minus m divided by NCn, where your PD is probability of defective items, small n is sample size, capital N is lot size, R is total number of defective items in lot, and m is number of trials by inspection. You can substitute the values and see that answer C is correct. Question 22. Which one of the following sentences is incorrect in reference to acceptance sampling? A. Accept or reject the entire lot based on sample result. B. Not consistent with TQM of 0 defect. C. MIL STD 105E is most commonly used sampling plan by automobile industry, and D. Judge whether quality level is within the level that has been predetermined. The correct answer is C, that is MIL STD 105E is most commonly used sampling plan by automobile industry. The reason is this plan is commonly used by military standards. Question 23. What will be the effect of acceptance number on OC curve? It means if you increase or decrease the acceptance number, what will happen to OC curve? Here you are supposed to evaluate in terms of increasing value of acceptance number. You can look at the 4 options A, B, C and D, and you are explained the effect of increasing acceptance number on OC curve and the other factors. Now, the correct answer is A. Increasing acceptance number does not significantly change the shape of OC curve, but producer's risk increases. Question 24. Average ongoing quality can be calculated as, you are given 4 expressions and you can immediately figure out that what is the right expression for AOQ. So, the correct answer is A. AOQ is equal to PA into P, probability of acceptance into percent defective bracket n minus n divided by capital N. The last question, question number 25. The mass of a tennis ball is 58.55 gram. One of the worker measures the mass and find it to be 58.54 gram, 58.55 gram, 58.52 gram and 58.6 gram in the first, second, third and fourth trial respectively. Which of the following statements is true for this measurement? A. They have good accuracy but poor precision. B. They have poor accuracy but good precision. C. They have good accuracy and precision. And D. They are neither accurate nor precise. The correct answer is C. They have good accuracy and precision. So, with this we are finishing with the solution of assignment number 7, and I hope this solution would have clarified all your doubts and would have given you the better confidence in dealing with the concepts and the solutions of various problems in Six Sigma course. Thank you very much. Next time I would be presenting the solution of assignment 8.